past. For those of you who participated in the raffle in the past, we have often referred to it as a raffle itself, and this year we're changing that to a fundraiser because I think what is often omitted is that this entire program, this operation exists to fund our mission, which is to perpetuate Alaskan general aviation. So what that means is that everything we do with this raffle, all of the proceeds, all of the revenue that comes in goes back into aviation in Alaska. So what that looks like is every year we purchase a Cub through a bidding process essentially. And it can be a Cub, it's been a 180 before in the past, it's been a 172 in the past. And this year we're excited that it is a Carbon Cub FX3. And we purchased that aircraft with some of those funds from last year, and then the remainder of those funds go toward funding things like advocacy in general aviation, scholarships, youth programs, the Great Alaska Aviation Gathering, etc. And I did see a question pop up here. I'll get to that in just a second. It's off my screen, and we'll come back to that. So I want to talk for a second about why we chose Cub Crafters this year. So the exciting thing about the FX3 is that it's experimental. And we are, for the very first time, breaking into that category for a raffle plane. And what that means is that 51% of that aircraft has to be built by the owner, which is. And what that means is that we can create a group of people essentially from young Alaskan aviation enthusiasts. So these are mechanics, these are fabricators, people looking to get involved in the industry. And so that group of people, we will send down to Yakima, Washington, and they will participate in the build process itself, which will be in November, and then we'll go back down early in the spring of next year to finalize that build. So for us, what that means basically is we have an opportunity to take young Alaskans and get them involved in aviation and teach them about careers and opportunities up here. So without further ado, I want to show you all some videos, get you excited about what we're doing this year. So I'm going to share my screen with you here, hopefully successfully. And then we will watch a couple of these. And they're not too long, so bear with me here, and they're quite exciting. Okay. Doug, give me a thumbs up if you can hear it when I play it here.
The FX3 really takes the best of the Carbon Cub and the best of the X Cub and kind of meets in the middle. Faster than a Carbon Cub, more off-airport STOL capability than an X Cub.
My estimation, the EX3 FX3 is probably the best airplane Cub Crafters has ever built. You have an engine that puts out more thrust, a constant speed propeller which allows you to climb the airplane really hard.
The Hartzell Trailblazer propeller allows you to manage the engine much better than a fixed pitch propeller would. You can turn up to 2,700 RPM on takeoff, getting full rated horsepower, turn the RPMs down in cruise for better efficiency and quieter cruise.
The engine needed to be capable of not only supporting the constant speed prop, but we also wanted to take the technology improvements that were available in our third generation. We worked with precision air motive on the fuel injection system, electronic ignition. We worked with the folks at Lightspeed. We also developed our own proprietary cold air induction system.
We built a carbon fiber plenum intake. We designed in SolidWorks, and through the flow testing, we could get it to where it flowed equal amounts into all four cylinders. Comes back to the state-of-the-art components that we're building to put in this airplane that makes it better than other aircraft.
The first flight I had with that 363i engine was quite eye-opening. The acceleration made quite an impression.
The control response for the FX3 and EX3 is considerably lighter. The stick on the FX3 I prefer over the FX2. I think the pistol grip that comes with FX3 is a real improvement.
Weight and weight savings was important through the design process, and every part of the airplane was looked at.
The fuselage, the wings, the tail, all of the major structure was analyzed for the higher speed ratios because the airplane performs at a higher speed. So we have an impressive capability to carry 900 plus pounds with an aircraft that has the highest thrust to weight in its class, which brings absolutely exhilarating performance.
The FX3 and the EX3 are identical aircraft. The difference is that the EX3 kit is built 100% by the customer. The FX3 is a builder assist aircraft.
All of the Carbon Cubs are very docile in the stall. In my mind, they're just an honest aircraft.
The Carbon Cub FX3 is my favorite airplane that Cub Crafters makes. Best all-around speed and STOL capabilities of any model that we make.
Okay, a couple of videos here to showcase the FX3 in action. All right, last one here, folks. Okay, everybody, on that note, I am going to introduce Brad Dom, who is with Cub Crafters. He's going to chat with you all about our airplane.
Hi, guys. I'm Brad Dom. I work for Cub Crafters. I work in the sales and the marketing side of the business here. And when the Airmen's Association approached us about doing a carbon cub and an experimental carbon cub for the Raffle airplane, we were really excited about it. We continue to be excited about it. We just had a group of young people here from that were sponsored by GAMA, the General Aviation Manufacturers Association, and they came in and did some design work and worked with our engineering department and those sorts of things. And we really, as a company, want to have a culture where we're bringing new people in, and we're trying to grow and maintain general aviation, and specifically backcountry general aviation. So that's part of our mission here that we do at Cub Crafters. Obviously, build and sell really cool airplanes too. And the FX3 is like Pete said in the video, I think it's our most capable backcountry airplane. It is a 180 horsepower IO 360, so a fuel injected 363 cubic inch displacement engine. It is a constant speed prop that gives 22% more static thrust than the 180 horsepower engine in the first generation Carbon Cub. So the airplane accelerates faster, it climbs faster. At 17,500 feet, if you ever go that high in a Cub, doing my test pilot duties I'd still climbing at 500 feet a minute. And it's an airplane that we really took a lot of feedback from our Alaska customers and built it into this airplane. So things like the heat in the airplane is one example. It has good front seat heat for the pilot. It has good rear seat heat for the passenger. It has heated windshield defrost. I don't know how many times I've gotten into a ski plane, snowy boots, turn on the heater hits my snowy boots, melts the snow, puts a bunch of moisture into the cabin, that comes up and hits that cold windshield and condenses on the cold windshield, and now all of a sudden we've got visibility problems. Doesn't happen with this airplane. It's got automatic alternate air. You're maybe doing a little bit of scud running, you get into a little bit of icing accidentally, or you flying through that 36 degrees snow and the front of the airplane gets plastered with snow all of a sudden. Well, this airplane's automatically going to take heated air from underneath the cowling, apply it to the backside of the air filter to melt the air filter out and keep the engine running. The panel we're putting in this airplane for the Airmen's Association, it's a really good VFR package, but it's also IFR capable. Now, no one at Cub Crafters claims that Cubs make good platforms for hard IFR flight, but there's times when you've got a marine layer or you've got an inversion. Been in that circumstance in Fairbanks a lot of times in the wintertime. You want to be able to file IFR so you can punch through that and go VFR to your destination. This is an airplane that'll do that and do that pretty easily. It also gives a lot of safety factor for this particular airplane. The VFR pilot that inadvertently gets into IMC and gets into trouble, there's a blue button on the dash. You push the blue button, autopilot takes over, flies the airplane straight and level. You can tell the airplane to do a 180-degree turn, and it'll do that while the pilot's calming down and figuring out their way out of that hazardous situation. So the airplane's got a ton of capability. Just gross performance specs. On 29-inch tires, the airplane will cruise at about 135 miles an hour true airspeed. It's a 2,000-pound maximum gross weight airplane. The one we're going to build for the Airmen's Association, empty weight should be about 1,150. So it'll have 850 pounds of useful load. Like I said, it has a lot of capability in terms of the engine, in terms of the avionics, 800 to 1,000 miles worth of range, depending on at a maximum economy cruise setting. You're not going to get that sort of range at 135 miles an hour, but pull back to about 110 miles an hour, the airplane will easily do 800 miles with a reserve. So that's kind of what we're building for the Airmen's Association. It's an airplane that I personally love, the FX3. It's an airplane we're super excited about having up there for the Airmen's Association. And a little bit about the build process. Cub Crafters offers the third generation Carbon Cub, which is what this is, both as a kit airplane that's been approved by the FAA as a guaranteed 51%. If we ship the airplane in a box to a customer, the FAA has already evaluated our kit so that the builder knows that they're going to meet that minimum portion requirement to qualify for an EAB certificate of airworthiness. But the other way you can do that is as a plans built airplane. And so the airplane that the Airmen's Association is building is technically a plans built airplane. And the people that are coming to Yakima to participate in the build, they will earn credit by helping to manufacture the core components that Cub Crafters will later assemble into the finished airplane. So they'll be running, CNC lathes and CNC mills. They will be putting ailerons together in a jig and doing some of the riveting on the ailerons. They'll be helping to build the airframe, not doing the welding, but helping to cut all the tubes for the airframe and put them into a jig so the welder, the skilled welder, can come behind them and do the welding. It is an intensive program. It's a 5-day program in the beginning, and then the same group will come back for, or part of the same group will come back for 2 days at the end of the program. And at the end of all that, it'll be a great experience. Everybody who goes through the program has fun. They learn a whole lot, and the final build tally will be about 53% on the FAA's checklist that the amateur builders will have accomplished at the end of the process. So that's kind of a brief overview of the airplane that we're going to build. That's a brief overview of how the process works. And I'll hand it back at this point here.
Okay, everybody, thank you for your patience. All right, thanks very much, Brad. I appreciate that. We are super excited to have Cub Crafters on board. This is an incredible opportunity. We see their planes up here all the time, and we'd like to see them more. So as we move along here, I want to talk a little bit about the program that we're doing with Cub Crafters before we get going into the preheating section of this webinar. So we are taking a group of young people, like I talked about before. That group is called Next Gen, which is the next generation of Alaskan aviation professionals. So they will come down to Yakima, courtesy of Alaska Airlines, which is really exciting. They're sponsoring that trip down, which is incredible. That's a lot of people going a lot of times. So we're very grateful for that. These webinars that we're going to put on for you will be a little different than prior live streams you might have experienced. In the past, we've discussed the build of the airplane, and we've gone over that process and showed you sort of that update by update of how the aircraft is progressing as it's built. We will still do that, but we're going to add in webinars that are useful as well. So like tonight, we're going to talk about preheating. There is going to be a Tanis preheater installed on the Cub Crafters FX3 that you could win. So we'll talk about that. That's super exciting. We will talk in further webinars. We'll hear from Northern Lights Avionics, which, if you're not from Alaska, is an avionics store down in Merrill Field in Anchorage, Alaska. And they're going to talk about some of their avionics that will be installed as well. So lots of useful information coming your way, so stay tuned for those. What I want to talk about here before we get started is other opportunities. So if you buy a couple of raffle tickets and you contribute towards our fundraiser, you're not just entered for an airplane. So yes, you can win this awesome aircraft, and we hope that you do. But there are also other things you can win. So I'm going to run through that list real fast because I want to get to the point here, which is preheating. So the first thing here, you could win 2 round-trip tickets anywhere Alaska Airlines flies. That's anywhere they fly. That's super exciting. You should look at their website and just explore where that might take you. A set of 31-inch Alaskan bush wheels from Airframes Alaska. If you're not sure what those are, check them out. They're incredible. A Garmin GTX 335 1090 from Northern Lights Avionics. We'll hear more about that in the future. A Premier Alaskan Tour package, which includes a private flight in a vintage DC-3. This is so cool. If you know what a DC-3 is, it's with Golden Era Aviation in Alaska. That'll be part of a tour package, which we'll detail more on later here shortly. There will be 2 flight helmets from Airborne Tactical Solutions, 200 gallons of fuel from Crowley Fuels, an ICOM panel mount VHF transceiver from Pacific Coast Avionics, a Garmin Montana 700i, which is an inReach system. It's the technologically advanced model that has the mapping and the texting interface that you can actually type on instead of having to use your phone or the directional keypad. And that does come with 6 months of the inReach subscription as well. And then finally, a 4 or 6 cylinder Tanis Preheat System, and that'll come with a Honda EU2200i inverter. And we chose that inverter because the 1000, which is lighter, 1000i that they offer, will power the heater itself, but it may not have enough for the space heater to go in the cabinet and warm up your avionics beforehand. So this way you get both of those with one system. So on that note, Doug, I'd like to introduce you and just talk about what you're going to be doing, and we'll hand it over to you and get started.
Great, thanks Will, and thanks Brad. Really excited to be joining with Alaska Airmen's again this year. We've been part of their Raffle plane build going on a couple decades now, and it's always exciting to see the people as they build it. And as Will explain, it's a little bit different this year with the experimental build on the FX3, but we have had our product on those. And I'm going to go through a PowerPoint presentation, but there's going to be a couple breaks in between for questions. I've tailored it primarily for the pilot, but also if there's anyone on that is also an A&P or an IA, we're going to go through some of the installation, some of the troubleshooting, and some of those tests that we do to help make sure that your item is running correctly. So I'm going to share my screen here, and then put any questions in the chat window. We'll be monitoring that, and when we have a break for questions, we will grab it at that time. So the basics of aircraft preheating, well, along with some of the installation and servicing tips. The cirrus that you see on the left-hand side of the screen there, that is a lake in the middle of Minneapolis called Mille Lacs. After all the ice houses get pulled off when they need to be off at the end of February, a resort and a bunch of volunteers plow a runway. Last year it was a little over a mile long, and we call it ice port. And then on the right-hand side, we not only preheat piston aircraft, but mini turbines, tons of helicopters. And this is the Erickson air crane that we fitted with one of our systems, what's actually in Canada, putting in the Trans-Canadian high voltage power line. So a little bit about Tanis. Tanis Aircraft Products has 2 locations in Minnesota. Welcome from the lower 48, as those up in Alaska always like to say. This is our Blaine location, where our sales, engineering, and accounting really happens. Where the phone rings, this is where the emails get answered. And our manufacturing facility is in Glenwood, Minnesota, where it's been for going on 30 years. A nice little small airport over there that if you get the chance, stop on by. We always have goodies to give people that walk in through the AD building in Glenwood, Minnesota. Most recently, if you haven't heard or seen via the press releases, as of July 1st of 2021, Tanis Aircraft Products is now part of the Hartzell Heated Products family of brands. Hartzell Propeller purchased Tanis on July 1st. And along with that, we became part of the Hartzell brand of companies. And you may not have heard of Tailwinds Technologies, but that's the holding company. Hartzell Propeller, a company over 100 years old. And Tanis now is part of the Heated Products, which is also heated props and all the products that we deal with. Some of the other brands, AWI, Aerospace Welding Incorporated, and Aerospace Manufacturing Incorporated, another Minnesota company in Eagan. Hartzell Engine Technologies, that has several different company brand names that you'll see underneath that: Janitrol, Plane Power, Aeroforce, Skytech, Fuelcraft, and then QAA, Quality Aircraft Accessories. So just want to give you a little clip on that, and then we're going to jump into preheat weather. This is the picture of our weather station in Glenwood, Minnesota back in 2019, minus 36 degrees. Good news at the dew point at minus 39, at least there's not much humidity in the air, but we call that Tanis preheat weather. And truthfully, what we really want to convey to you, whether you have a Tanis preheat or any type of preheating system on there, is why are we telling you and talking to you about preheating? And of course, Alaska is really in the middle of our strike zone when it comes to customers that need our product. We do it to reduce the engine wear, increase the engine life. Many batteries now are not forward of the firewall, they're after the firewall. So we have battery heating that heats up that battery. You want to be able to start it. You want to make sure if you're in a flight school and you got a new pilot that hasn't really figured out how to start it in colder weather, you don't take that chance of frosting the spark plugs. And we even see a ton of the use of our product in open cockpit and warbirds because of all the oil that's in there that has to get up to temp prior to flight. Prevents cylinder scoring. As we know, there's a taper in the cylinder, and the dissimilar metals of the air-cooled aircraft engine expand at very different rates. And just because you have oil pressure doesn't mean you have oil flow. So that's another reason why you want to preheat. And we recommend preheating all the critical driveline components. If you heard Brad talking about a constant speed prop and accessories that might be involved with that. It truly does increase safety, and that's why Tanis' tagline is aviation safety starts with Tanis Preheat. And last but not least, the engine manufacturers do actually mandate preheating at certain temperatures. If you look at Lycoming or Continental's handbook, you will see that they tell you basically they'll go at it a little bit differently, but if your engine is 20 degrees F in that 20-degree area, they say you must preheat prior to starting that aircraft. So this is Tanis related. What are our goals when we design a preheat system for an aircraft engine or an airframe that we've never dealt with before? First and foremost, we want to make sure that we're able to heat those cylinders. It's a multi-point preheat system. We want to be able to heat the cylinders at least 50 degrees above the ambient and produce an oil temperature at least 40 degrees above the ambient. But one thing here is when you're externally warming up your oil, you don't want to have it exceed that 120 degree Fahrenheit. And never do we want to have it warmer than the cylinder. And I'm going to jump into a little physics here about the dew point and condensation. So we have a caution, here comes physics. But if you think about your oil sump, when you're done flying, that crankcase is full of moisture. It's almost 100% relative humidity and probably close to 180 degrees. That moisture will all condense, sit on your oil, eventually go down to the bottom. That water will evaporate due to just the normal physics around it. But as you increase the delta between the temperature of your oil or the water and the dew point inside your aircraft crankcase, that rate of evaporation will speed up. And that's the critical part. You know, think of if you're in Alaska or even Minnesota, you leave a washcloth, wet washcloth sit out in the summertime, high dew points, it stays wet for a day or two. In the wintertime, when we're heating and the dew point and the humidity in our house drops quite a bit, it is dry in no time. And that's that evaporation rate that it speeds up. So we have a multi-point preheat system that heats everything above the oil line warmer than the oil. So you think, you know, whether you have 4 quarts or 7 quarts or anywhere in between there of oil, we want to make sure everything above that is warmer than the oil, which of course is also the water and the moisture that's entwined with your oil. And that will make sure that is a physical constant. You cannot condense moisture on a piece of metal that is warmer than the dew point. And that's really the reason why you can leave our system plugged in all the time. And we'll talk about it as we go through the next 45 minutes here in the presentation of why you can, why, you know, what you should or should not do. But that is the meat of what our presentation really wants to do. Why should you preheat, what you should preheat, and why it's so important you think about that temperature of the engine. So it's easy for me to say this, and you know, you've heard all the various stories that are out there that usually don't, are not accompanied with engineering facts. So we really want to make sure the tests that we do is something that you can do in the hangar yourself, especially nowadays when you have a glass cockpit. This isn't quite what the FX3 looks like, but boy, darn close. The minute you slip that master on, you're going to be able to tell what your CHT temperatures are and what your oil temperature is. So you can see that delta, and you can also see, hey, do I want to start this engine now when my oil is this temperature or when my cylinders are this temperature? I give you that information because what we want to prove to you is we are gathering this data all the time. This is our NIST calibrated data logger that we use to capture temperatures of various engines. You see these are the calibration labels on each one of these items. And we actually physically go out to customers' aircraft and do these tests. So this is a customer that we went to. It was a flying club with several different aircraft, and we did a mapping by taking those thermocouples, you see these brown wires here, and embedding it up against the cylinder, the outside of the cylinder, opposite of where we're heating the cylinder, putting ones on the case inside the oil. So if you see the bunch of 100-mile-an-hour tape you see there, that's one that has our thermocouple sitting inside of the oil so we can get the oil temperature. And then we'll also do the ambient temperature at the same time. And yeah, it's in a hangar and it's cold. I don't remember what the temp is here, but we do it with engine covers on, engine covers off, cowl plugs in, cowl plugs out, always gathering this data so that you too can actually see how we're gathering that data, and you can prove this out yourself. You can actually take a look at it and say, here's how it's happening. So here, let's jump into some of this data. This should be near and dear to one of the people that are on this webinar tonight. This is an FX3 that resides in the metropolitan area, the Twin Cities of Minnesota. Got a kit put on. Oh, I don't have the date on here, so Trent, you'll have to chime that in, but you'll see what we're talking about. We want all 4 of these cylinders to be warmer than the oil, and the oil is the green line right here. So this is the oil, and of course, it's going to take longer to heat up the oil than the cylinders because it's got more mass. And we really want to see this delta every time. And we want to make sure the temperature is in a range that we feel comfortable to start the aircraft. And if you see here, we're starting this with, you know, ambient temperature in the 60s. So yeah, you can preheat in the 60s. The oil temp isn't above that 120 where we don't want to see it. But that is how we gather and capture data on customers' aircraft. Another airframe, a 172, we were doing this at the same time that we were certifying our avionics cabin heater. So again, you see this delta, and you see the oil, how it cools, and you'll also see, here's a 15-degree Fahrenheit night. When the ambient temperature dropped to 10 degrees, you'll also see how our temperature just rides that ambient curve. So everything we do really builds up to the fact that it's X degrees above ambient, whether your ambient is 20 below zero or whether it's 40 degrees. We'll talk a little bit more about what if it is 20 below zero and you need that extra heat. So that's the other reason you don't want to put a timer on it or a thermostat inside your hangar that says, hey, every time it gets into freezing, I start preheating. And then once it gets above freezing, it shuts off, because what's going to happen is our cylinders, so you see right here is an 1.5 hour mark. We get 50 degrees above ambient in that first 1.5 hours. But if we were to unplug it, those cylinders are going to be the first ones to cool off because they have less mass, and the oil is going to stay warmer than that. And now you set yourself up again for a condensation possibility. Again, not a concern if in fact you're going to fly it right away, but if it sits there for many, many days, now you have an issue of condensation on a rocker cover to start with, valve, top of my cylinder, cylinder walls, and then starts the issue. So what if I'm in Fairbanks and it's -30 and I have to fly? Then we do a test, and this is pretty much true. This was on a 177, but almost identical on all the airframes and engines we deal with. You'll get our 50 to 60 degrees above ambient with in an unheated hangar or with cowl plugs in. And then if you add an insulated engine cover, you'll just about double the effect of that temperature rise. So you can get from 10 degrees Fahrenheit here up to 110 degrees. So you can get that 100-degree temperature rise. But as you notice, it takes quite a bit longer. So you're going to have to plug it in the night before. This is 6:30 a.m. and this is 4 o'clock in the afternoon. So you see that was 10 hours of heating time to get that extra heat if I truly need that 100 degrees above ambient. And sometimes you're doing a data log on something and you bring the data back into the office and you look at it and you say, what the heck is going on here? Of course, you know, it didn't get printed out when we looked at it with this on the side of it. this was a flight school that they tuck in about 10 aircraft every night, big hangar door. And, you know, they tucked this one in. We started the data logging at 12:20. And then at about 7 o'clock that night, the hangar door goes closed. And that little up and down temperature of the cylinder is just the natural airflow going in and out of the cowl openings. There weren't any cowl plugs, wasn't any insulated engine cover on this one. We just left it wide open. And this shows you, A, how effective our air-cooled baffles are on our cylinders, but B, how important a set of cowl plugs or an insulated engine cover is for our engine to gain and maintain that temperature. It is really, really important. If you see how much those cylinders bounced up and down, and you know, it even as the temperature dropped down later on that night, we got more heat going through that aircraft. We will test any type of scenario. We had a customer that said, "Hey, Doug, we don't use your system, but we use your insulated engine cover, and we have a sump only, and eventually everything's going to be the same temperature because we got an insulated engine cover on that." So we said, well, let's go prove that out. Let's see what happens with that. So we started with the Citabria. You know, it was 20 degrees Fahrenheit, and we plugged it in with that insulated engine cover on and left it on from 9 a.m. in one morning to the next afternoon. And you will see that whole period of time, this is my cylinders here, and this is my oil temp. And that is basically proving to you that a sump only will heat up the oil, will do a fair job of heating up the cylinders, but you're still setting yourself up for an issue. Again, not a concern as long as you flew somewhere after this time here. But let's say it got fogged in and all of a sudden you couldn't fly. Now what are you going to do? Are you going to be able to fly within the next week? Well, that moisture is sitting on top of your cylinders. We took that, we didn't, their aircraft maintenance facility took the sump only engine system off, put ours on, and again, here's the part that we're talking about. And the ramp up is so quickly. Here, this is 9 o'clock, and right here is 2 hours later. I'm terrible at drawing on the screen, but we get that 50 degrees ramp up in a couple hours. It happens very quickly. And we even go out to places not necessarily close to us. This gentleman lives in Wasilla, Alaska, and had a 6-cylinder UL powered Zenith going together. And we hadn't developed a system for the 6-cylinder UL power. So during the Airmen's meeting in May of this past year, I stopped on by. We did a data log of his aircraft and determined what we needed to do for wattage and type of heating that we needed to do for his aircraft. So I'm going to stop right there, Will, and I see there's a couple questions in the chat. Is there anything else that anybody else has for questions at this time? If not, we can just go roll right on by.
Okay, the first question I see here from Arn, is there a way for the winner of the airplane to get a repairman certificate? Arn, forgive my ignorance here. What is a repairman certificate?
Brad, you want to take that question?
I can take that question.
Okay.
So an amateur builder can qualify for a repairman certificate, which allows them to do annual inspections on their airplanes. For airplanes in the LSA class, like a first generation Carbon Cub, that's a 16-hour course that a person goes and takes. They have to pass a test at the end of it that's blessed by the FAA, and they get what's called a repairman certificate. For an EAB airplane or experimental amateur built airplane, that repairman certificate is issued by the FSDO where the airplane was built, and only the original builder of the airplane would qualify for it. So in this circumstance here, no, the winner of the airplane would not qualify for a repairman certificate. The EAB airplane, the owner of the airplane, the new owner of the airplane, they'll be able to do all their own maintenance. They'll be able to change spark plugs, change oil, all that sort of stuff with just a simple logbook entry. The annual inspection will have to be signed off by an A&P, not an IA, but it will have to be signed off by an A&P in this case. Does that answer the question?
Great job,
and then I had a question for you. What sort of wattage does a Tanis system draw on a 4-cylinder engine?
Great. We're going to jump into that in the second part. 4-cylinder engine is 240 watts. It's low wattage, very, very efficient because we put it inside. We'll actually go into deeper amount of data that later on this presentation. The 6-cylinder draws 460 watts. So any other questions on there, Will?
No, I'm not seeing anything, sir.
All right.
Oh, hang on, here we go. We got one more popped up just now. Engine preheat kit, 6-cylinder, Continental, Lycoming, and Franklin STC at 115 volts. Is this the heater you recommended?
Correct. Well, we have two basic systems. Our STC 4-cylinder system handles all 4-cylinder Lycoming, Continental, and Franklin engines. And our 6-cylinder 57 kit handles all of the Continental, Lycoming, and Franklin engines under those part numbers. So if you have a 6-cylinder, it's our 6-cylinder kit. If it's a 4-cylinder, it's our 4-cylinder kit. Okay, so I'm going to jump in now into a little bit of installation, but we'll also get into some of the wattages and the questions of how do I know if everything's working. First of all, our website has all the data you need. You do not need to buy a system to download the documents. You have to register on the website, but if you wanted some key installation documents or finding out, hey, how does this work? How do I handle doing certain things? The way we do that is you log into the website and away you go. You don't have to actually physically buy a system to do that. And these are the documents that will lead you into that. And that is this area on our website right here under document search. You go in that upper right-hand corner. Type in the document you want. You'll be able to download it. Here's a case of our installation instructions for our 4-cylinder kit, where we go through and tell you various things on how to install it. One thing that this carbon kibble will have in the FX3, we also include what we call our circular plug bracket. You'll see this installed on Trent's aircraft here later on. It's a place to house and firmly hold the shore power plug so you can plug it in with one hand, because normally in Alaska at least, you have an insulated engine cover sitting on there, and you have a oil door that you're popping open, and you have a extension cord in the other hand, and you kind of need that third hand. This really helps make that an easy install. So if you see here on this FX3, you will see that is mounted to on the oil fill tube with self-fusing tape, hose clamps. The hose clamp goes around the plug, and then you have that plug permanently mounted in one place of the aircraft. And here's what it looks like with the cowl back on. We also include an indicator light. So when you do get this plugged in, you literally have the ability to know that the power is coming through your cord into the system and the fuses are not blown, because otherwise that light would not illuminate. So we do have various types of plug mounts. People a lot of times will ask us, our employees at our trade show, what's the #1 fail point? The #1 fail point is if you don't firmly mount your shore power plug and it bounces around, whether it's our system or anyone else's. It moves around. That's an electrical wire. You bend an electrical wire enough times, it's going to break. So you see our flush mount plug that we have here. If you are a person that has a Bonanza or a Cirrus, you'll see that it will be a real nice install with a flush mount plug. Or we have brackets to go on to the Continental with the Sandcast, or push and clamp arrangements so that you can firmly adhere a power plug to an area so that it doesn't bounce around. And yes, that is how big the power plug is, because we want to be able to mount something directly on that. We also have door kits. Obviously, we're on a bunch of helicopters. We will then have single place, double place, 3-place, and even all the way up to 4-place door kits that can be mounted onto the aircraft. Last 2 years, the Raffle plane had either a flush mount plug or a single place door kit on the side of that 180 that was in the boot cowl. So you can just go up to the side of it and plug it in. And so as I'm going through this, some of the installation tips, one of the things, if you are working on this yourself, this wonderful little slotted 1/2-inch socket that we sell for probably cheaper than you can try to make your own. I think it's $15 or $16. That works so good at installing these 1/4 by 20 bolts. We replace a rocker cover bolt or an intake tube. We used to be in the CHT well. We vacated that a couple decades ago with the advent of engine monitors. But that item right there makes it so easy to do the install of the threaded elements. And we'll show you here later on what happens on the pad elements. Back in 2010, we went to this type of connector for everything. It's the TE Lad Deutsch environmentally sealed connectors. So if you have male and female spade connectors on your old system, we're going to try to encourage you, if you're buying a new element, to go to our current kit, and then we will sell you a connector kit that you will cut off the old spade connector on your harness and have something that you can plug it in and out. But of course, in the 70s, the male and female spade connectors were high tech at that time. And that's what the connectors look like. And we'll give you an instruction on how to remove these and install these. And then you'll see we call them sockets and pins based on what's inside of that connector. So install. This is Trent's FX3. We did the install, worked with him to do the install on the intake tube location. This is on the co-pilot side of the engine. Replaces that intake tube, and that will be one in each cylinder, along with, well, now here's an example of what the SR20 looks like in the factory at Duluth for the Cirrus. Again, they use that intake tube location. We also, the exact same fastener will replace any one of your rocker cover fasteners. So depending on your airframe, your engine, really depends on where to do that type of install. This is the SR22. Just about every aircraft that has any type of, I think it's flight into known ice option, they will have our system installed at the factory. Hey, Will, you got a question?
Yeah, we've got one here in the chat. Let's see. MSS iPad Pro says, I rent a hangar and would like to know how to estimate the cost of running the Tanis on my C-180 0470. Electricity is included in rent, but I don't want to take advantage of the landlord. Excellent. I fly weekly from South Central Wisconsin. Thanks.
And the engine was, what was the aircraft again? What's the engine?
Cessna 180 with an 047.
600. Yeah, so you're going to have 460 watts is going to be the power consumption. So every 2 hours, you're going to use not quite a kilowatt. So if you're paying Wisconsin, I'm going to guess you're somewhere around 15 cents a kilowatt. So take 12 times 15 cents, that's your cost per day to run that preheat system. One other thing that I did want to mention, you'll see running the wire. Where do we include a wiring harness, and what we really want to make sure is this wire per the guidelines has to be secured every 6 inches. And you'll see what they do at Cirrus at the factory. They run it right up along the side of the top of the engine, and they have cushion clamps that hold every one of those clamps very solidly. Our 4-cylinder is going to have one pad that's glued to the bottom of the sump. A 6-cylinder needs a little bit more heat because it's got more weight, and the top of the case is bigger. So you'll have a pad on the bottom of the sump and a pad on top of the case. And here's just a brief way of showing you how to do the install. That's what the pad looks like. That's the bottom side of the pad. It comes with a tube of bonding adhesive, which is basically Dow Corning 732 clear. You go ahead and put that on the bottom of the pad, take a putty knife, make it nice thin film all the way across so you can see that it's all wet. You adhere it to the bottom of your sump, and it'll take anywhere from 6 to 8 hours to cure. So it's a moisture cure, humidity cure type of adhesive. And then what we also recommend is once it's done that overnight, then take silicone and go around the perimeter of that pad so that you have kind of an extra bead to go around the side of it so you don't have oil or any other way of product getting underneath it or wanting to stick to that pad. There again is that Cirrus, the factory in Duluth. When I said a 6-cylinder, you're going to have one on top of the case and one on the, well, that's not their sump, but that's a sump. That's our traveling trade show sump. And that's the Cirrus SR22 with a Continental on the bottom of the sump. Here again is the FX3. The 4-cylinder pad is a little bit smaller. Again, we do it based on the weight and the amount of wattage that we want to put into the sump, and that is just a great place to put on that FX3. We also have, for some places that have the cross flow type of sump, we do have what we call oil sump screen elements or sump elements where it's just a brass body, and then you'll take a plug out or the oil sump screen and replace it with our element. And the reason people go that route is they will actually have time out an engine quite regularly in a flight school. And that if you put that silicone pad on really good, it's really hard to get off. But if you use a plastic putty knife, heat it up a little bit, you're able to get that pad off, but they're like, no, let me just unscrew it and screw it back in, which you can do with our intake tube or rocker cover locations. So I can see when people just go up there, let me look at the chat. Okay, we already answered that question. Did you see anything else come in? Bill?
No, I didn't. Anybody else have a question?
All right, if you have one, just pop it into the chat and then we'll open up the end. So what if, how basically the question should be stated, how do I know my preheat system, my Tanis preheat system is working? And this can go for probably just about anybody's. Once you know what your total wattage is or your total ohm value for the kit, when it's installed brand new, then you can do some really simple things to determine. That's our 4-cylinder kit. Remember, our 6-cylinder kit's 460 watts, and our 4-cylinder kit is 240 watts, 55 ohms for the 4-cylinder and 28.8 ohms. And this is all plus or minus 10%. But one quick and easy way is to go to your big box retailer or small hardware store in the local town and buy a watt meter. You know that our 4-cylinder system draws 240 watts. Plug that into the outlet that you're plugging it in at. If you're plus or minus 10% of that 240, you know every one of the elements is working. The 6-cylinder, if you're plus or minus 10% of that 460, you know every one of your cylinders or every one of your elements are working. That's really the quickest and easiest way. Most people will go in and stick their hand on it, and yes, you will get a lasting impression. If you do that on some of our threaded elements, it will rearrange the skin on your hand a little bit. Another way is by an ohm meter. You've seen that our 4-cylinder was 55.1 ohms. Put the ohm meter on the plug, and you know if you have any element out. If you have higher, much higher, because obviously this is above 10%, you know there's an element out, because resistance, the lower the resistance, the more heat you get out of something. Ohm's law formula. So as I raise in resistance, I have elements that are not working, and vice versa. If I see this 0.4 ohms, I know I have a shorted element someplace. So leave the ohm meter on there. Again, these are Deutsch plugs. Unplug them one at a time until you see that ohm meter jump back up to this value, and then you're like, okay, that's the shorted out element. That's the one I got to replace. I put this on here because we made this change about 5-6 years ago. Our fuses, we always have 2 fuses on all of our wiring harnesses, because our wiring harness doesn't know if it's going to be a 115 volt or 230 volt system until it gets assigned to the elements. So we have 2 ceramic slow blow fuses that are embedded inside of here. We used to have a 1/4 turn cap type of fuse arrangement that was very easy to pop the fuses out. Unfortunately, it was also very easy to crack the cap on it, and we wanted to make something that was a little bit more waterproof and foolproof from damage. So this is our current fuse arrangement. It'll be within the first 10 inches of the power plug. So if you see it, we had one person calling up and saying, I can't find any fuse. Turn this around. I think we do have the injection molding printing Tanis fuses on both sides of that. And as we get out to the end, so we don't only preheat air-cooled engines, we do a ton of helicopters, EMS helicopters. This helicopter was used also to put in the high voltage power line, Trans-Canadian high voltage power line. This is how they were preheating 2 years ago. And then we designed a system that heated all of the critical driveline components, the main rotor gearbox, the tail rotor gearbox, fuel control units, mod motors, accessory motors, even put cabin heaters, avionic heaters inside the cockpit to give a little bit of creature comfort inside of there. And now they just go out there with a generator and plug it in, and they don't have to be lugging around and keeping doors open when the snow was blowing in that part of Canada. A little plug for a product that we just got involved with here a couple of years ago. We bought out a company that was doing texting type of remote starts. And then as we did that, we wanted to bring it up to new technology. Another company came on board from Kansas. We've now partnered with them, and we are making this device called a Switch-on. And basically that is a data controlled device that you can turn on your preheat system. We sell either 2-channel or 4-channel units, and you use the data band of the cellular towers, not the text, not the cellular, but the data band. So it's using the LTE-M. We've had an amazing success with it. Usually that we're out of stock most of the time. We happen to have them in stock right now. And if you're interested in that, obviously go to preheatremote.com or our website, and we can help you out with those. No, Will, I didn't include that with the Raffle plane, but you know, our arms could possibly be twisted. And then if you want to come and join us the second weekend, either the first or second weekend in February, we have Winterama in Glenwood, Minnesota, where we cut a nice great big hole in the ice. And no, it's not just 5 feet deep, it's 10 feet deep. And we jump in for a fundraiser for the Waterama, and we invite somebody else to go with yours truly and make that over there. And we'll have a nice warm place for you to change into your jumping gear, and a nice warm place to change back out of it. And then we also will test your confidence and competence for doing that. I'll leave my contact information up there for a little bit, and then I'll stop the share and see if there is any other questions that people might want to ask at the end. But that's our contact information. That's my direct in-dial number, but this number, these 2 numbers here, gets you to our sales technical support, and you'll get a real live person that you can talk to that understands our system. So that is my presentation. Again, as we stated in the beginning, we had a great relationship with the Alaska Airmen's and the Raffle plane. And I know that it's a little bit different this year, being built in Washington. But I think if you look deep into the mission of the Airmen's and Next Gen, you'll see how this really meets that to the T. Toss it back over to you, Will.
Okay, thanks so much, Doug. Can you guys hear me okay? All right, great. Before you all take off, I just want to take a second and explain how you can get your hands on your new FX3. So if you would like to purchase tickets, you can do so at our phone number, which is 907-245-1251. And you'll have to call us between 8 and 5 Alaska time. It's currently 6 o'clock Alaska time, so we'll be available tomorrow. Unfortunately, we can't do it online. The Alaska gaming laws prevent us from doing so. We will have kiosks throughout the state as well that you can access. And I will put some of that information up. Oh, Doug's already ahead of me. Right on. Okay, folks, any last questions before we head out here? All right. Well, Doug and Brad, thank you both so much. Folks will post this online here the next day or early next week. So thanks so much for tuning in, and hope you learned something today.
Thank you, Doug.
Thanks, Will. Thanks, Brad.